Hello dear students of plus 2 medical and non-medical respected teachers. Today I am going to discuss methods of production of induced EMF. So there are three methods by which we can produce induced EMF. First is by a relative motion between the magnet and the coil, as in case of Faraday's experiment. So because we have to simply change magnetic flux, there are a number of ways. So suppose in Faraday experiment we have coil AB connected to galvanometer G and a bar magnet with north pole downward. When this bar magnet is moved now with north pole downward towards the coil, galvanometer gives deflection say towards left and current is anti-clockwise. When it is taken away, direction of galvanometer is reversed say towards right and direction of current becomes clockwise and A becomes south pole where it is downward and A becomes north pole. So, and when there is no relative motion between the magnet and the coil, there is no deflection. And the deflection of the galvanometer is also seen when magnet is made stationary and coil is moved towards or away from the magnet. It means it is immaterial whether the coil is moved or magnet is moved. But there should be relative motion between magnet and the coil. So whenever there is relative motion between magnet and the coil, the galvanometer gives deflection and hence induced EMF is produced and current is also produced. And the cause of this induced EMF is change of flux. When we move magnet towards or away from the coil, number of magnetic lines of force threading the coil change and hence induced EMF is produced due to change in magnetic flux. Second, we can produce induced EMF by changing area. So suppose we have a rectangular frame PQRS conducting frame and with movable arm AB having length L placed in a uniform magnetic field B shown by these crosses. So this plane of coil plane of frame lies within the plane of the board and magnetic field is directed inward normal to the plane of the board. Now when this movable arm AB is moved towards right, say from position AB to position A dash B dash with velocity V and distance moved during time dt, suppose it will be v dt. So we move the movable arm AB. As a result, area of this portion changes. Area increases, magnetic lines of force threading this area will increase and hence magnetic flux will change. So by changing area, we can change the magnetic flux. So during time dt, if dA is the increase in area, so dA will be equal to LV dt, length into breadth, or corresponding to due to change in area, there will be change in magnetic flux. So change in magnetic flux d phi is given by BdA because B is uniform, or d phi is equal to BLV dt. Differentiated we have d phi by dt is equal to BLV. Question number 1. And by Faraday's law of EM induction, induced EMF produced is directly proportional to rate of change of magnetic flux, or E is equal to minus d phi by dt, or numerically if we compare 1 and 2, so we get E is equal to BLV. So induced EMF is equal to the product of magnetic field, length of the movable wire and speed of the wire. And direction of Fleming's direction of induced EMF is given by Fleming's right hand rule. So what is Fleming's right hand rule? Stretch your right hand so that first finger, central finger and thumb all are mutually perpendicular to each other. Now if first finger points in the direction of magnetic field, thumb gives the direction of motion of the conductor AB, and then central finger will give you direction of induced EMF, that is from B to A. So induced EMF will be from B to A in this case when it is moving away from the arm RQ. So again, right hand thumb rule, first finger gives direction of magnetic field directed inward. Thumb gives the motion of the conductor. Central finger gives the direction of induced EMF. So we can find direction of induced EMF by using Fleming's right hand rule. So then third method is by changing orientation of the coil and the magnetic field. Suppose we have magnetic field between two pole pieces of magnet north and south from left to right, uniform magnetic field. And suppose coil is rotated in this magnetic field. Suppose coil makes an angle theta with the normal to the plane of coil makes angle theta with the direction of magnetic field. So B the magnetic field in this case is the area vector. So B is in this case direction and this is the area vector. So angle between B vector and A vector is theta. So then magnetic flux is given by, for one turn of the coil it is BA cos theta, for if it has n turns it will be phi is equal to NBA cos theta, or theta is equal to omega t, or phi is equal to NBA cos omega t. Question number 1. Differentiating with respect to t, so we had d phi by dt is equal to NBA d by dt of cos omega t is minus sin omega t, and we had to multiply by coefficient of t omega, so it will be minus NBA omega sin omega t, or transposing, so minus d phi by dt is equal to NBA omega sin omega t, or E is equal to NBA omega sin omega t by Faraday's law of induction, because induced EMF produced is equal to minus d phi by dt. So this gives expression for induced EMF produced by changing orientation, and the number of turns, B the magnetic field, A the area of coil, and omega the angular frequency. So for E to maximum, sin omega t must be equal to 1. It means NBA omega is equal to EM. This is called peak value or maximum value of induced EMF. For numericals, you have to remember this equation. So maximum or peak value of EMF is given by NBA omega, or E is equal to EM sin omega t. And from this equation, by dividing R, we can find instantaneous current I is equal to E by R, EM upon R sin omega t, or EM upon nothing but IM, so I is equal to IM sin omega t. So E is equal to EM sin omega t. This is instantaneous value of induced EMF, and I is equal to IM sin omega t. This gives instantaneous value of induced current, and as it is periodic, so it means it is alternating EMF and alternating current. Moreover, it is EM sin omega t, it is IM sin omega t. It means E and I are in phase. So if you plot graph taking E or I along y axis and omega t along x axis, so if it is E, it will be like this, and I will be like this, small p, but E and I are in phase, means crest of E is falling upon crest of I, and trough of E is falling upon trough of I, and which is nothing but alternating current and alternating EMF. And this is the principle of AC generator. So AC generator is based upon this production of induced EMF when we change the orientation of the coil in a magnetic field. So this is all about methods of production of induced EMF. So stay tuned for next video. All the best. Be happy. Good luck.